Hello and welcome to lesson 7.2, dot product. So we're going to find out how to actually calculate a product between two different vectors. And this is only one type of product. There are actually multiple different types of products. So the dot product is described as, I'm going to visually draw two vectors here. So let's say I have a vector u and I have vector v with an angle of theta between them. I'm going to change vector v to be a little larger. Okay, so in order to calculate the dot product between these two vectors, it is described as u dot v is equal to the magnitude of u times the magnitude of v times cosine of theta. So this is the dot product, or sometimes also called scalar product, because the result will be a scalar. Now what it actually does is it takes the horizontal component of the vector u, so this distance right here, which can be calculated just by taking the magnitude of u cosine theta, and then takes the size of vector v, which is this distance right here, and multiplies the results. That's what this value calculates. It's used to describe some various different things, and we'll talk about that as time goes on. So let's try calculating it. So using what we know already, calculate your dot product of the following expression. Pause your video and try it out. Okay, so now that you've tried it, this is what you should work out. U dot v is equal to the magnitude of u times the magnitude of v times cosine theta, which is just 6 times 11 times cosine of 51 degrees. So the value of u dot v turns out to be approximately 41.5 units. We'll talk about the units later. Okay. So some properties of the dot product. If the vectors u and v are ever perpendicular, then u dot v actually equals 0. This stems from the idea that if they're perpendicular, like this, then cosine theta actually turns out to be 0. And that's why the magnitude, or the dot product of these two, actually equals 0. Because u and v can be arranged in any format, u dot v is equal to v dot u. Also, if you have two vectors that are exactly the same, so u, and you take the dot product between these two things, because the angle between them is 0, cosine of 0 degrees is actually the value of 1. So all you're doing is just taking the magnitudes and multiplying them. So u dot u just turns out to be equal to the magnitude of u times the magnitude of u, or the magnitude of u squared. Okay, some other properties. The vectors u and v are associative, with the value k being a real number. So if you take u dot v and you multiply it by k, you can also multiply k by any of the other two vectors and still apply the dot product. It also follows a distributive property. So if you take u dot v plus w, just like expanding the u into the v and the w, just like with regular multiplication. And by far one of the more interesting things, if u is equal to a1, b1, and v is equal to a2, b2, the dot product is just the product of the components added together. So let's see how we can use these properties to simplify some problems. So let's say we have ku dot u plus v. Well, according to our properties, what we can do is we can take ku and dot it with u, and we can also add ku dotted with v. Well, according to our properties as well, k of u dot u can be written as magnitude of u squared. And therefore, we can get this expression. Okay, well, according to the distributive property, again, we can take the u plus v and we can dot it with the first expression. And we can also dot it with the second expression. We can also rearrange these. So let me rearrange it. So now I get vector v dotted with vector u plus v. From here I can distribute again. Oop. Gonna do the same thing here, sorry. So we can get u dot u plus u dot v minus v dot u minus v dot v. Well, again, what we can do is rearrange. So I'm going to rearrange the u dot v here. Well, u dot u can be written as the magnitude of u squared. These two expressions are the same value. We can cancel them out. We can subtract the magnitude of v squared. And there we go. We can simplify this expression. So let's calculate some values. Assuming u is the vector 2, 3, and the vector v is negative 5, 7, we can calculate u dot v. So this is how you write it. So we write 2 times negative 3, which is negative 10. You don't have to show the calculation there unless you want to. 3 times 7 is 21. Together, this equals 11. There's the value of u dot v. As you can see, it is just a scalar. It's not a vector. Let's try that with u dot u. So 2, 3, dotted with 2, 3. So 2 times 2 is 4. 3 times 3 is 9. Together this equals 13. And the magnitude of this thing would just be square root 13. Okay, let's try one more calculation here. Let's calculate the angle between the two vectors. This is an application of what we see. Okay, so we know u dot v is equal to the magnitude of u times the magnitude of v times cosine of theta. So from part A, I know that u dot v was the value of 11. From part B, I know the magnitude of u was 13 square root of. Just need to work out the magnitude of the vector v, which was -5 and 7. Okay, so this is going to be -5 squared plus 7 squared, all under a square root sign. So -5 squared is 25, 7 squared is 49, together makes up 74. So to find out cosine theta alone, take the value of 11 and you divide by square root of 13 times the square root of 74. And therefore, theta is the cosine inverse of that value. Please do not use approximations of square root 13 and square root 74. Put those into your calculator exactly. Otherwise, your angle will turn out to be approximated even further and not be accurate. Plugging this into my calculator, working this value out, I get an angle of 69 degrees, approximately. And thus concludes this lesson 7.2.